Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our M&Ms. This is for homework 5.3.4. These M&Ms are, honestly, it's nothing in here that's really going to be life-changing as far as formulas or anything goes. But it does describe what we talked about in our lesson, the whole concept of consecutive integers. These kinds of questions will pop up periodically when we're solving these types of 5D process problems. And they're kind of like puzzly sorts of problems too. So consecutive integers, as we saw in the lesson, have to do with three numbers, three integers that are right in a row on the number line. So 11, 12, 13, 4, 5, and 6, 28, 29, 30, those would be considered consecutive integers. Now, this is where things get a little interesting. If you have consecutive even integers are 2 apart on the number line, right? Because it goes even, odd, even, odd, even, odd, even, odd, and so on and so forth. So if they're going to be consecutive even integers, we would not include the 11 or the 13 or the 15. So it would be 10 plus 2 is 12, 10 plus 4 is 14, and 10 plus 6 is 16. The same pattern holds true with consecutive odd integers in that they are all spaced 2 apart on the number line as well. So notice that the consecutive integers would be x, x plus 1, and x plus 2. If we were to solve it algebraically, we would say, like, all right, 3 consecutive integers have a total sum of, oh, let me make up something right now. Oh, shooby-dooby-dooby-dooby. 3 consecutive integers would have a sum of, oh, hold on. I'm going to pause. I'm having a brain, you know what? Hold on. Okay, so 3 consecutive integers, I've got it now, have a sum of 18. So you would take x plus 1 plus x plus 2, which becomes 3x plus 3 equals 18, which means that the 3x's would have to be equal to 15, because you take away the 3 from the 18 to get 15. And now what do you multiply times 3 to give you 15? That would be 5. So the 3 numbers would have to be 5, 6, and 7, right? So that's how we do the 3 consecutive integers. If I were to say 3 consecutive odd integers have a total sum, hold on, let me think of something. If I were to say that 3 consecutive odd integers had a sum of 75, we would take x plus 2 plus x plus 4, so that becomes 3x plus 6 is equal to 75. Then I would take away 6 from each side, and that would give you 3x's equals 69, and then divide by 3, and you get x is equal to 23. So the 3 numbers would have to be 23. 23 plus 2 is 25, and then the next one would be 27. So 3 consecutive odd integers, right? They're all odd numbers. They're all odd integers. So when you add them together, gives you 75 for an answer. So you'll see that pop up occasionally. If you've got this neatly written into your math notes, you'll have no trouble at all solving these problems, because you'll just look at the math notes, you'll see what the pattern is, you'll plug it into your equation, and then solve the equation. All right, so let's get to our homework. Get you out of there. So think about the mathematical process you use to solve the following problems. Show your work and your solutions. So if there are 10 students in a room and 40 of them are boys, how many are girls? Well, that would be the complement, right? 40 taken away from 100 equals 60, so it'd be 60 girls. If there are 17 blue and white stripes on a flag, and 9 of them are blue, how many of them are white? 17 minus 9 is 8, so there'd be 8 white stripes. If there are 250 pennies and dimes in a box, and 130 of them are pennies, the rest of them have to be dimes. So 250 minus 30 is 120 dimes. So now it is time to generalize. Imagine you know how many items you have in a collection of 2 things. If you know how many of one there are, how could you find the other? Well, subtraction is the key in all of these situations. Subtract the known quantity from the total. All right, let's look at some proportional reasoning. If you travel 156 miles on 4 gallons of gas, how far can you go on 12 gallons? Okay, so we can set this up as a proportion, and what some students might like to do is some students may look at this and decide to turn that into a unit rate. But in this case, I don't think we really need to use the unit rate because it's so easy to use our giant 1. So 4 times 3 is 12, so 156 times 3 will give us our answer of 468 miles. We can do the same thing here. If you know that you multiply 1.5 times 6 or times 4 to give you 6, you can multiply 156 times 1.5, and that would give you our answer of 234 miles. Now, let's see what the unit rate is. What is 156 divided by 4? 39. So in this situation, y is equal to 39 times x, where 39 is the unit rate, the number of miles per gallon, and x is the total number of gallons used. So y would end up being the total number of miles that you can get on x number of gallons. So if I multiply 39 times 12, I should get 468, and I do. And then I can multiply 39 times 6, and that would give me 234. Now, some of you may have noticed this. Some of you may have noticed, well, if it's 468 miles for 12 gallons, then half of that must be 234 miles for 6 gallons, and that is another wonderful use of proportional reasoning. Totally makes sense there. So you're just wrapping your brain around the entire concept of proportional reasoning, realizing there are lots of different ways that you can approach a problem and solve a problem. Just whichever way makes most sense to you, use that strategy. All right, this is distributive property, the whole sending in the die bombers. You've got a quantity inside of parentheses, and you've got a multiplier on the outside. So you're not just multiplying 4 times x. If all you had to do is multiply 4 times x, we would write the expression like this. But there's parentheses around the x plus 2, which means you're actually technically supposed to add those together first, but you can't because you don't know the value of x. So the only other thing to do is to rewrite it as an equivalent expression. So you send in the die bombers, 4 times x is 4x, and 4 times 2 is 8. Here, negative 5 times 9 is negative 45, and negative 5 times x is negative 5x. And then here, 7 times x is 7x, 7 times negative 3 is negative 21. And order of operations, this has really been very popular recently. So I don't want to go through and do all of these if you don't need me to do all of them. I'll do a couple. Let's do, maybe I'll do E and F. Start with E, where there's no parentheses other than this guy, but there's nothing inside to simplify, so we can move on to exponent, but there's no exponents. We'll move to multiplication. Here's a multiplication process where you go 2/3 times 6. You multiply the 2 times the 6, and technically there'd be like a 1 there for the denominator. So this becomes negative 12 over 3, which is equal to negative 4. And then we have to do the division part here. 15 divided by negative 3 is negative 5. So when you add those two quantities together, because that's what we're doing here, we're taking, let me go ahead and clean this up a little bit and get rid of that. You take this quantity here, that's one term. This quantity there, that's the other term. Simplify each one of them individually, then add them together, and you get your answer is, oh, stop it. You get your answer is negative 9. Okay. Go. Move out of the way. Okay, now we're going to do this one. First thing we have to do is inside the parentheses. So it becomes 5 squared minus 5 divided by 5. Then we have to do the exponent. 5 squared literally means 5 times 5, so it's 25 minus 5 divided by 5. And in this case, the most common wrong answer is people take 25 minus 5, which is 20, and 20 divided by 5 is 4. So if you got 4 for your answer instead of 24, then you accidentally subtracted before dividing, and dividing is the higher priority. So 5 divided by 5 is 1, so you get 24, no, you get 25 minus 1 is 24. And now, little scale factor. Enlarging and shrinking shapes. So find the lengths of the missing sides on similar shapes at the right. What is the scale factor? So scale factor, I don't know how much time we spent talking about scale factor, but scale factor can be described in 2 different ways. if we find the corresponding sides, right, same side on each of these shapes, this is the smaller shape, this is the bigger shape, if you figure out what is your multiplier, what would you multiply times 22 to give you 33, that's going to be your scale factor. But sometimes it's not easy to figure out what that multiplier is. So if you take those two known sides and you write them as a ratio or fraction and then simplify the fraction, 33 divided by 22 is 1.5, so your scale factor has to be 1.5. Now, you could also write that scale factor as a simplified fraction, which in this case would be 3 over 2. Now, the reason why I like writing it as 3 over 2 is because this process can be a little bit confusing sometimes. The scale factor is 1.5, but sometimes it's hard to tell whether you're supposed to multiply it or divide it to get one of these unknown quantities. So I always tell my students, you can think of your scale factor as 3 over 2 or 2 over 3. It could be either one, because the formula for scale factor is to go from the original to the new. And so if this was the original and this was the new, then we would want to have 33 in the numerator and 22 on the denominator. But they don't really clearly tell you which one is the original and which one is the new. So I just think of it this way. If you multiply a number times 1, it's always going to stay the same, correct? If I multiply a number times another number that's greater than 1, it'll get bigger. And if you multiply a number times a number that's less than 1, it'll get smaller. So if I take this ratio of 3 over 2 as my scale factor, if I want to find out the value of z, this number is 15, right? And z is on the bigger shape. So this z must be larger than 15. So I'm going to choose the larger of the scale factors and multiply 15 times 3 over 2, which becomes, let me go ahead and write this, 15 over 1 times 3 over 2 becomes 45 over 2, which then becomes 22.5. So z must be equal to 22.5 millimeters. Same thing applies for y. If I take, let me go ahead and change colors here, the 54 and the y, you're going to multiply 54 times something to give you y, which is bigger than 54. So we're going to have to once again choose the 3 over 2 scale factor. So this becomes 54 over 1 times 3 over 2, which is, what is that, 162 divided by 2 ends up giving you 81 for your answer. Now, take a look at this last situation. Our known information is the 40 and the x, and x is less than 40. So I don't want to multiply this times 1.5. Technically, I would divide it by 1.5, but some students get confused by that. So I just say always stick with the multiplying, okay? X is shorter than 40, so we'll have to choose the scale factor that's less than 1. So if we multiply 40 over 1 times 2 over 3, we get 80 over 3. And when you take 80 and divide it by 3, you end up getting 26.6 repeated, or you can write it as a fraction, 26, or mixed number, I should say, 26 2/3 millimeters. So we're going to do a lot of work with scale factors as we move forward, and it'll pop up again in 8th grade in chapter 6. This is the approach I prefer you to take. Not necessarily memorizing the formula for how to find scale factor. This can be confusing, and it could also be completely wrong if you accidentally put the original on the top and the new on the bottom because you thought that's what it was supposed to be. So I'd rather you not memorize. I'd rather you understand why we do what we do and then apply it in this way. And that's the end of our homework. Hooray. All right, let's move on to the next challenge, our next activity. Bye-bye.
Hey, feeling good, like I should.